So, today I will discuss how to measure the focal length of mirror, basically concave mirror and convex mirror. So, if I give you a mirror, so how you will identify whether it is concave mirror or convex mirror, right. So, I have a mirror here, you can see I have a mirror. So, this mirror, this face is this, it has, so in both face basically mirror, in both face basically mirror. So, which type of mirror it is, either concave or convex, how you will identify. So, you know that convex mirrors all the time, always it will give virtual image and erect, straight, erect, okay. And concave mirror, it will give inverted image as well as erect image, inverted real image as well as virtual erect image. So, that depends on the distance of the object from the mirror, right. So, you know that if the object is at the focal point of the concave mirror, then image will be at infinity. Now, if you increase, now if the image, if the object distance from the mirror is less than focal length f, then we will get the virtual image and erect image, right. So, when object distance is less than f, we will get virtual image and erect image. When the object distance is greater than f, we will get real image and inverted image, right. So, that is for the concave lens, and convex lens, all the time for all distance of the object you will get the erect image. Virtual and erect image means virtual image all the time it is erect image, and real image is the inverted image, right. So, say I have a needle here. So, if I see the image of the needle in the mirror, then we can identify whether it is concave or convex. So, this one, let me show you this. I can see the image, but I can see the image of the mirror, image of the object in the mirror. Now, if I change the distance of the object from the mirror, so whether it remains, the image remains all the time, it is erect. So, then we will say that is the concave convex mirror. If when it is very close to the mirror, if it is erect, and when we will take away from the mirror, then after particular distance of the object from the mirror, we will see that the image is inverted. So, I will show you, to show you I have to just look at the mirror and the object, okay. So, look, so can you see? So, now it is very close to the mirror. So, we are seeing the erect image. Now, I am changing the distance, so it is still erect, all the time it is erect, right, all the time it is, for all distance it is erect, okay. So, that means this mirror is is convex mirror. Okay. Now, other side actually two mirrors is attached to here, two mirrors are there. Okay. So, if I see the other side of this mirror, so that is now you see that you can see the uh, you can see the erect image. Okay. Now, I am changing the distance, I am changing the distance. So, it is becoming diffused, it is becoming diffuse. Okay. It, so, so can you see inverted one? Now, it is a quite so this is the erect image. Now, I am changing the distance. Now, I am changing the distance. I am changing the distance. Now, it should be inverted. Okay. So, now it is become inverted. So, that means when this object at close to the mirror, so image was erect. So, virtual image. Now, when distance is higher, that means distance will be greater than the f basically. So, I am changing the distance and it, so erect image becoming the inverted image. So, then you can conclude that this mirror is the concave mirror. Okay. So, that way I can identify basically the whether it is concave mirror or convex mirror, right. So, this way one can identify the mirrors whether it is concave or convex. That is what I showed you. Now, I will demonstrate one experiment here today, this how to measure the focal length of a concave mirror, So, this is the concave mirror, this is the another concave mirror. Okay. So, this concave mirror we fixed on a frame, and this we tell generally is upright, it is fixed with an upright. Okay. So, this mirror is fixed with this frame, and this we tell this upright. Okay. Now, this mirror, that's there is a index line. Okay. There is a index line here that I kept it at 0. So, it should not be parallax error. So, I kept it at 0. Okay. So, here this is the optical bench, it has scale, and it has upright, different upright. So, this is the one upright where index line is there. So, that we use for the taking the position of this upright. So, in this upright we have fixed the mirror. So, this mirror is basically concave mirror. Okay. Now, let me tell you how to measure the focal length of a concave mirror, So, so working principle for this experiment, is basically this you have a mirror, concave mirror, right. Now, you have an object, okay. You have an object. So, needle object basically, So, it is sharp tip is there. Okay. So, now this from this position of the object. So, this basically we will see the image of this object in the mirror. How this image is formed, where we will see the image, whether it is virtual image or real image, whether it is inverted image or erect image. So, that will depend on the basically distance of the object needle from the mirror. Okay. So, here object needle, if we put between f and the 2f distance, between f and 2f distance. Okay. So, then for this position, object position say O, now light, use the ray diagram. So, light is coming from this point. Okay. So, it is going this way. So, this light is passing through the focal length f, passing the focal length f, it is falling on the mirror. So, you know light passing through the focal length. So, that will fall on the mirror and it will be reflected, that reflected ray will be parallel to the principal axis. Okay. This is the principal axis. So, that earlier I have discussed importance of uh, three rays, right. So, if rays passing through the focal length, so reflected one will be the parallel to the principal axis. So, that way we have done. Second, this light from the same point, if it is parallel, if parallel light to the optic principal axis falling on the mirror, then it will be reflected ray will pass through the focal length, pass to the focus, right. So, it will pass to the focus. Okay. So, these two reflected rays, where they will meet, where they will cross, there basically at that point we will get the image, we will get the image of the point, corresponding point of the object, right. So, this point will be the image of the object point here. So, similarly from all points of the object, so light will fall on the mirror and we will get basically we will get the image. Okay. So, that image, since distance is greater than f, we will get the inverted image and real image. So, image basically we will see through the, we will see if we look at the mirror, we will see image is like this. Okay. Image is like this. Now, so this is the object. So, object distance from the mirror is u, right. And now, we have to find out the position of the image. Okay. So, to find out the position of the image, so we will take another needle. Okay. And that needle will move this, needle, and we have to find out the position of this image needle. Basically, this we tell image needle and this object needle. So, position of this image needle will be such that when we look and shift our eye left and right, then the tip of the image and the image needle will move together, they will not be detached. Okay. So, but for other position you will see when you are moving your eyes left and right, so you will see that this tip, their tip position, so they will detach from each other. Okay. So, at a particular position we will see this they will move, this image tip and the image needle tip will move together. Okay. So, that is the parallax method. Okay. So, this way one can find out the position of the image. Okay. So, when you will find the position of the image, so basically on the optical table you need to fix the mirror, an optical bench, note down the reading of the mirror. Okay. And then you fix the object needle. Okay. So, how you will know that where you will fixed? Okay. How we will know this it is greater than f, this value is greater than f. So, that you can find out as I told this take the needle, object needle very close to the mirror, then you will see that is you will see the erect image. Now, when you are moving, so you will see a particular point where you will see this image is very hazy, you cannot see this image. Okay. So, and move further, then you will see this erect image is converting towards the inverted image. Okay. So, approximately you can you can find out that this the focal point of this mirror. So, you should take a distance from this distance from the mirror where, so starting from the near starting from the near to the mirror, erect image you will see. Now, you are moving, now it is hazy. Now, after that, so you are basically crossing the focal length, then you will get the clear inverted image. So, keep this object needle at this point. Okay, at this point. Okay. Now, that is the distance reading you can take from optical table, and then you have to find out the image position using the image needle. Okay. So, you will get then reading of this optical image needle from the optical bench. So, you know the reading. So, difference between these two reading will be the u, and difference between these two mirror and this image needle. So, that will be the v. So, if you find out the u and v, so you can calculate the focal length of this. So, u and v as per the sign convention, they are negative. So, you will get the value of f also negative. Okay. And obviously, you can see this this is the focal length, this is the focal length, and it is so whatever the direction of the light. So, focal length is basically from mirror. So, we have to go against the direction of the incident light. So, that is why it is expected that it will be negative. So, that is what it is so f is negative. So, it is concave mirror. Okay. So, now I will demonstrate the experiment and you have to so this is the data table for u and v. Okay. So, that experiment we will do for different position of the object, means for different u value, okay, object distance, and corresponding image distance we will find out, and basically you will get u and v. So, one can calculate 1 by u and 1 by v also. So, one can calculate focal length when you know the u v. Okay. Also, one can use the graphical method to find out the focal length. Okay. Okay. So, I will demonstrate in next class. So, I will stop here. Thank you for your attention.